G'day there, you're watching the Aussie BIM Guru, and you've reached part 2 of my 2-part series on using Revit and Dynamo in order to get your Revit floor plans into Power BI. In the last part, we had a look at a few things. So we've managed to get our room boundaries into a shape or SVG file. We also simplified the edges of rooms that had arcs or splines into single segments so we could form polygons in order to frame the outside of our room cleanly as a shape element. There's a starter file that you can access on my GitHub at the link below. This will let you start at the same point that I'm starting at here, and I'll also upload a cleaner version of the final script to my GitHub as well at the end of this workflow. So we now have a shape file that looks a little bit like this. It's essentially a list of polygons, but in this case there's one thing missing. In this case we do want to add the ID, which currently isn't present in our shapefile at the moment. It's just the polygons and their points. We rely on this ID to connect these shapes to the elements in Power BI in our Excel data. So we're going to be focusing on inserting this component into the structure of our shapefile. Dynamo can luckily read and write a shapefile like a text file, so we're going to take advantage of this by splicing in the data. You might need Synoptic Panel at some point during this tutorial as well. It's a custom visualization that you can download and install into Power BI, which I'll be doing a little bit later on in the video. But feel free to download this custom visual as well so that you can actually load your shapefiles into Power BI. So we can do things that look a little bit like this. This will be the goal by the end of the series. So picking up where we left off, what are we doing? Well, we're going to be splicing in our data into our shapefile and also generating an Excel list of data that we can connect to our shapefile within Power BI. We're going to use Excel as our data source, and then we're going to use the Synoptic Panel and the data source in order to build that custom visual relationship between the two pieces of data. You will need some custom packages. So we've already used data shapes in order to start off our user interface, and we've used Crumple and Illustrator as well, and I'll be using Crumple for one more node in this workflow as well. I'll be using Revit 2020.2.3 and Dynamo 2.3. Anyway, let's dive in. So where we last left off, we generated a floor plan in Dynamo to a shapefile. So this is just a custom project I had that I picked because it had a couple of arcs available in some of the shapes of the rooms, which is quite good. So it gave us something to fix. So we essentially built this script, and it does a few things. So it generates a user interface at the start to begin the process. After that, we check all the rooms in our model, and then we're essentially filtering them down based on the levels we select in our user interface. We're then processing our boundaries that the room contains to take the largest boundary if multiple curves are present, which can sometimes happen if a floor has like a hole in it, like a donut. From there, we're implementing an algorithm that essentially breaks down splines or arcs into segments so that we can build a regular polygon, which we do at the end. We're also mirroring our results across because you'll find that in Power BI, the custom visual will need to be mirrored to look down like a floor plan. From here, we exported to an SVG or shapefile. So I actually have this shapefile available currently. So it's this file here. And at the moment, it just goes polygon points. Now we want to insert a little bit of text in between this on each row depending on the room's data. So in this case, each of these rows represents a room. So we're going to be inserting the ID as well. So we're going to go and build this little piece of data to insert. Now we're going to go a fair way back in our script to do this because we're going and drawing on our rooms themselves. So we're going to go all the way back here to this filter by Boolean mask. In this case, I'm going to need to get a couple of strings, and you're going to need to make sure you type these out fairly carefully. And we're going to put these into string nodes as well, so that we don't have to worry about any sort of escape characters or characters that might be misinterpreted in a code block format. So we're going to open a caret, type in polygon in lowercase, space, ID, equals, and then a double apostrophe. So this is the leading portion of the ID of our element, and we're going to be replacing polygon at the start as well, because we're going to use polygon as a match for a find and replace workflow in the text of the file. So every time we see polygon, we're going to replace it with a bigger piece of text. I'm also going to be getting the element ID of the room, because this is something that's unique to the room itself. So we're going to get the ID of these rooms that we end up with. I'm then going to close my string, And in this case, on the end of this, I'm going to put another double apostrophe after the ID, and then just the word points. And this will get us back to the point where our point list begins. Excuse the pun. Now I can put these three elements together. So I'm going to go X plus ID plus Y. X being our prefix, Y being our suffix, and the ID being our ID. Now if I run my script, I'll just need to set a few of these things again whilst we work. So I'm going to say 250 raw data. I'm going to delete my current shapefile so I can write a new one. And I'm just going to call this working file. I'm just going to make sure I'm pointing to an actual Excel file. So you make sure you have an empty Excel file to point to, because we are going to start using this file quite soon. But for now, I'm going to generate, and this will go and generate a shapefile from the last tutorial. But now we also have this little fragment of text that we're going to insert over the top of that leader of each line that represents our polygons. So we might just group this together, because this is quite an important little piece of the script. And we're going to keep this for later. So we're going to go a little bit further ahead in our script now. We're going to go back to where we generated our shapefile. Now we do want to make sure that everything that happens after this point happens after the shapefile component of the script has run. So I'm going to use a node. Sorry, cat's gone crazy in the background there. I'm going to use a node from my package called waitFor. There are other types of nodes that do this. Await, pass through. I think there's one in the Orchid package as well. But in this case, I'm just going to use my waitFor. And I'm going to pass through my directory. So I'm going to go all the way back to my inputs and collect my first input. But I'm going to wait until my export of my shapefile. Now, shapefiles are exported very quickly. So you should usually find that you'll be able to access this file relatively instantaneously in Dynamo without any problems. Note that the shapefile isn't actually outputting anything. It's just outputting a void. So it's just saying it's done. It's not actually passing any data forward. So we're just waiting for that node to run, essentially. I'm now going to build a little code block. And in this case, I need to add a few things together. So I'm going to say directory plus, and in this case, I'm going to make a string. Now I want to put a backslash in here. Now, if I do this in a code block, it doesn't actually work. What we've done here is used what's called an escape character. Typically, if you put this in front of any character, even another backslash, it tells the string that you're essentially trying to put in an illegal character in the string or something that the string wouldn't accept. So we need to put 2 in order to put a single backslash in our string. A little bit of a strange concept, but it's very common in most programming languages, such as Python. I'm then also going to add my name of my file, which we've just generated as an output in our user interface as well. And I'm going to add the file suffix .svg. So we're essentially building the file name so we can refer to it. I'm now going to take my directory, and I'm going to go back and get my name of my file as well, which is one of my outputs. In this case, I believe it is my third output. Yes, it's my third output. And this is just so we can reference our file by path, because this doesn't pass through the file path of the element. So in this case, we're going to be using a special node called filesystem.readText. And we're going to be reading the contents of our text file. So we're going to take that file path, and we can actually access the entire contents of this shapefile. So now we can see everything in here, including this polygon points leader on the front of each line. So it's pretty cool because it means we can obviously go and rewrite this as a string now, a multi-line string, which is really powerful because it means we can essentially modify and splice elements onto this file. Now at this point, I'm going to run a find and replace routine. I couldn't really find a good way to do this in Dynamo, so I decided to write one using Python instead. It's a very simple Python script, so if you don't know how to use Python, don't worry, I'll run you through it, but it's a very basic Python script. So you're going to create a Python script, and you're going to add one extra input. Now our first input is our file. Our second input is going to be this special list of new front lines to each line. And essentially, we're going to be searching for something to match. In this case, it's going to be that polygon points leader, and we're going to replace this with our special leader on each line. So we're going to be using an iterative function, which means we're going to keep going through one at a time on each string, and we're going to be replacing each occurrence of something that will basically be replaced each time we run a replace routine. So we know that we can go line after line and replace each of those with a successive list of replacements, which sometimes the replace node for strings doesn't do well in Dynamo. So the first thing I'll do is define my old string. What's my old string? My old file contents. And this is the input at index 0. I'm then going to take my replacements, or I'm just going to call it replace at input index 1. I'm going to build a for loop. So I'm going to say for rep in replace. So I'm creating a local variable called rep. And this is basically each item in the list of replacements. And I'm going to say that old string is equal to old string. But to that old string, I'm going to make a modification. I'm going to replace, and I'm going to be replacing the string caret polygon points apostrophe. And in this case, I'm also going to be replacing it with the replacement, so the local variable. And then after that, I'm going to be replacing it just once each time. And after this, I'm just going to make the output my final old string once it's finished running through each iteration. So what we're doing here is basically changing an immutable object. So we're replacing something with itself. So in this case, if I just save and run, we should expect to see an output where each of those leading figures has been replaced. Now we can see that we've inserted or overridden each line with its respective ID replaced line as well. And at the end, we've still got all the information on the back end of our shapefile. So pretty cool, right? I usually like to keep this here just to be able to watch what's happening. If I rerun this script, it shows me a lot of the contents of what's occurring at this stage. Now, something I've noticed as well, when you pass data through Python, some of the apostrophes get switched between single and double apostrophes. From what I understand, shapefiles typically expect these to be double apostrophes. I'm not sure if that's always the case, but I have noticed I get inconsistent results when I don't go and replace all the single apostrophes with doubles. So typically I run a second find and replace, and this one's much more simple. This one I can just use a string.replace node. And I'm just going to be searching for a single apostrophe. And again, I'm going to be using a string node to host this because it can be quite hard to represent single and double apostrophes, given that when they're used in a code block, they represent the beginning of a string. And I'm replacing all my single with double apostrophes. I usually like to create another watch node here, just to make sure that everything has worked. And I can see now that all those single apostrophes are now consistently double. At this point, I can just rewrite my text. So I can get a file system.write text. I can go back and retrieve that file path again. And once this is all done, I'm just rewriting that portion of my text file. So I'll just save and run. And on the back end of this script, we should now have a rewriting component as well. So pretty cool. So I'm going to update my file. So one great thing about Notepad++ is it detects when a file's been updated and it prompts you to reload it. So in this case, I might just go, I think that was an old file. I'm going to reload the new one, which is called working file. But now you can see we've successfully inserted our ID inside the header of each row. So each room now has an ID we can reference in the synoptic panel visual, which is pretty exciting. Now the last thing we need to do is generate some data to Excel for our rooms so that we can match our data between the visual. So we're going to go all the way back to the start, or almost back to the start, back where we generated our rooms. Back here. And we're going to retrieve some data from these. So in this case, I'm going to call on the element ID. And I'm also going to retrieve some parameters by name. I'm also going to get the room names as well. So first I'll just take this in list and I'm going to retrieve these. Now I'm going to want to get these to all sit at a very particular level so I can join these with some parameter values at a similar list level. So I'm actually going to work at level 3 in both cases. And what this will give me is a list structure that looks a little bit like this. So it's a very particular list structure, but it's essentially a sublist inside a list. Actually, sorry, level 2. So I need to be a sublist, I think is what I'm intending for. Yeah, so I need this to be a sublist. That's better. Sorry about that. And what we're going to do now is we're going to get a parameter value by name. And we're going to take our rooms. And instead of using 3 get parameter by name nodes, I'm just instead going to use a list of parameter names and use some list levels. So I'm going to build a list and I'm going to get 3 parameters. I'm going to get the department of a room. I'm going to get the area and I'm going to get the level. You may recall that level comes back in the form of the name of the level, which is perfect. It's just a string. So if I work at the standard lacing for this, it won't really give me what I want. If I work at longest lacing, I'll get something that looks a little bit like this. So it's still not really what I want. What I need to do here is say, for this list of elements, I want to search for every single parameter of each of those elements in the list. Now I'll get 3 lists, 1 for each parameter across each room. Because I've worked with these at very particular levels, I can now apply these similarly in a different way. So I'm going to turn the element ID into a string. First of all, just using a string from object. And I'm going to use a list join. So I'll just search for join. And I'm going to join these 3 lists together. My ID, my name, and my get parameter by name. And assuming I've kept these all at the same levels, I should just end up with five little lists, which is exactly what I want. And they're all sitting at the same level, which is perfect for Excel. I'm now just going to transpose this list. Oops. So we're going to flip these. So the columns are now rows. So now we'll get one set of data for each room. And we just need to add some headers to the front of this list now, so that in Excel we have some headers and in Power BI we do as well. So to this list, I'm just going to add a header row. So I'm going to copy this set of parameter names. You could source this set if you really wanted to, but I'm just going to add 2 extra ones. So I'm just going to say ID and name, and make this just a slightly longer list of strings. And if I run this now, we'll have a list of headers on the front as the first row. From here, all I need to do is export my Excel data. So I'm going to get an export Excel node with my data. I'm going to get my file path, which in this case is the only input we haven't used yet. And then I'm also just going to set a few properties, such as my sheet name to write to, which is sheet 1. My start row and column will be 0, and I will overwrite. So sheet 1, 0 and 0, and overwrite. And that's it, that is the script. So it's a pretty big script. I will upload a clean copy with some annotations on it to my GitHub if you just wish to use a more clean version. But this is, one of the biggest scripts I've probably put on the channel. So if you have got to this point, congratulations. Regardless, I'm going to hit run. And you can see that all my Excel data is now written, which is great. And my shapefile is now up to date as well. So now for the fun part, we get to go into Power BI. So I'm in Power BI desktop here. I'm just going to get data and I'm going to retrieve my Excel data. So at this point, you can pick a lot of different data types in Power BI. It's an amazing software. We're just going to get our Excel data. So in this case, I'm just going to go grab book 1. And it'll prompt you to pick a sheet or sheets of data. I'm just going to pick sheet 1. In this case, I believe I may have written to a different file actually. I'll just double check where I located my file. I think in this case I probably picked, I picked somewhere else. Whoops. What I might do is just run this again from scratch, and then I'll just have a data source that I can draw upon. So we'll run this all in one. So from start to finish, it should look like this. You set your directory. In this case, I'm just going to do my desktop. Segment length, let's go a bit smaller, let's say 250. I'll call my shapefile name working data. I'll pick an Excel path on my desktop this time. And I'll just, I'll probably just copy an old Excel file. And just call it Excel data. And I'll pick just a few levels, ground, carport, and lower ground. So essentially all my rooms on ground. Generate, it'll generate my Excel file. In the background, it's written my shapefile and added the pointers on the front as well. Now we should be able to draw upon this. So I might just refresh in this case, and I might just cancel and do this again. So I'll just import some data from Excel. So now we have our Excel data. Now we should have some data in sheet 1. Perfect. So I'm going to load my data. And one thing you may need to do sometimes is you might need to change the unit type for the area column. Sometimes it comes in as text. So we're going to go to this tab here. It looks like in this case like it's coming as a decimal number, but do make sure your area is a decimal number. And ideally, if your ID can be a whole number, that's great, or text. Either one will suit. So let's begin. So in this case, we're going to just probably first import our custom visualization. So this synoptic panel. So I'm going to import. And I'm just going to find a copy of synoptic panel. I've got a few lurking around my machine. I'll just copy one to my desktop and load it in. And you should see it show up around here somewhere. There it is. The first thing I'm going to do is just place down a table so I can actually see my data. And I might just make this a little bit smaller. Okay, so let's just drag and drop a few fields on. We'll take ID, we'll take name, we'll take area, and maybe level. Now in this case, ID is not quite working in this case. We're going to make it don't summarize because currently it was doing a count, and we don't want to count our IDs. We just want to see each unique ID. So that's better. So now we can see all our data in a table format. Let's drop in a synoptic panel. To begin with, it won't have anything. So the two things you'll need to add first are ID to both the category and the measure. I'm then going to load in my SVG file from that button on the top left. So working data SVG. And check it out, we've got our floor plan. It's in and it's pretty much ready to go. Very simple, very straightforward. So I'm just gonna do a bit of resizing. Let's try selecting a room. Check it out, it's all responsive. So it knows which room is which based on the ID. Even though I'm not selecting the ID, I'm selecting the data row that contains that ID, which is enough for the synoptic panel to relate this back to the shape that has that particular ID. Really exciting, so really straightforward. So that's probably the hardest part done. A couple of other great visuals you might wish to introduce might be a pie chart by department. So we can add in a legend and value. And maybe we'll just turn off the detail label. And we can generate a little pie chart so that we can also filter by set. So you can select more than one element at once, depending on the types of visuals that you introduce to Power BI. So you can see here I can pick all of my rooms that belong to the department for general areas. Maybe I want to pick my plant areas. And you can see that all my data filters and is sliced to suit what I nominate. Maybe you want to see the areas as well, and maybe you want to see them totaled. So you obviously could see them here, but maybe you just might wish to introduce a card. So for a card, we can just say we want to see the area, and we want to see the sum. Now when I filter down, I'll get feedback on the area of what I have selected. Maybe you want to see a card that's based on the name. Well, in this case, we could introduce another card with the name. Now in this case, you will need to pick either the first or the last name in the set, because obviously sometimes you won't have just one room selected. But if you do have one room selected, the first name will just return whatever you choose to select. So you can see that you can start making some really interesting and interactive visuals for someone going through your Power BI reports. So really fun, and I think it's a really great way to open up some possibilities in there. It's really quick and easy if you want to generate another one too. So I might just save this and call this ground floor. Let's say we want to do a study for the first floor of this building instead. Well, it's just as simple as reopening the script. And you could run this from Dynamo Player as well. I'm going to make a copy of my Excel data and just call it first floor. so that we can keep our old data preserved. I'll run my script to boot up our user interface. In this case, I'll just save to my desktop again. Make my segment length 250 for consistency. My shapefile name, I'll just call it first floor. And my Excel data, I'm going to path to my first floor file. I'll now pick all the level 1 levels in my project. Generate. It's going to generate all my data. It's going to run the same process just for the level 1 rooms, and it's generated the shapefile and rewritten the IDs. So back in Power BI, it's just as simple as changing my visual to first floor and changing my data source. So in this case, I believe we may potentially have to, I don't know if it's easy to repath to a new source. I haven't done that before. I think it is possible, but just to save myself a bit of time, I might instead just rename these files so that they repath over the top. So I've just replaced my Excel data file by name. So if I refresh the path, now everything is synced up with this level instead. So you can see it's really quick and easy to redivert different data and different visuals. And you can see that using Dynamo, we can pretty much switch between other projects and other levels and visuals very quickly and very easily, which is a lot better than the original workflow that I uploaded to the channel. So I hope you found this useful and an interesting application for Dynamo and also for Power BI. So if you do want to see the final script, or you just wish to access the final script, it will be available on my GitHub. But I do encourage you to try and build the script, or at least explore it, as it's a great way to learn more about data processing in Dynamo and programming in general. So thanks for watching. I hope you really enjoyed this. I really enjoyed putting this together. It was a great little script to experiment with. It's been a while since I've done a big workflow like this. So I probably will go back to some more simple workflows after this one, but it was just a nice change from some of the simpler content I've been making. If you're not already following and subscribing, feel free to do so, and I look forward to seeing you in future videos. Thanks. Take care. Bye.